Everyone, welcome back to SAT Math Question of the Day. We're taking a different tack. We're saying about a con, and we're going to do SAT questions that we found on the internet. So here we have one, the absolute value. Well, those bars mean the absolute value of x plus 3 is 6. The absolute value is a function where the output must be positive. It must be positive.
Or zero.
Or zero, yes. It must be positive or zero. So that's telling us that x plus 3 has to be 6, but x plus 3 can also equal negative 6. Because if this thing is negative 6, the absolute value of negative 6 is 6. So it satisfies the equation. So then we just can solve these and see which one is positive, which x value is greater than 0. So it looks like it's 3, right?
All the choices are positive.
No. Which is the positive? So you're right. I misspoke. We solve it and we see which of these two x's gives you when you solve these two equations, which one has an x that's greater than 0?
No.
No?
It's a stumbling approach.
Okay.
Okay. They are asking for the positive solution.
Yeah.
The solution is the x.
Absolutely, of course.
That makes the equation true.
Absolutely.
And then the choices are these 4.
Yeah.
And all the choices are positive.
Okay. Yeah, but not all the choices are correct.
So all you have to do is figure out which of these 4 numbers has the property that when you plug it into here for x, the absolute value of the result is 6. Well, these are all positive.
Right.
When you add a positive number to 3, you get a positive 3.
Right.
And so in for all the choices, when you plug in one of these positive numbers for x, the number you get is given by the formula x plus 3. So you find the x for which x plus 3 equals 6, and the only x for which, when you add it to 3, you get 6 is 3.
Yeah.
End of problem.
Yeah, so in other words, in this problem, Joel did overkill. Yeah, you didn't have to really...
So what's the approach? Read the question. Read the question.
Right.
Oh. Read the question. Approach 2, which is an approach that works only on multiple choice questions on tests. It does not work in the real world. Look at the choices. Okay? And then use your brain. Think about about simplifying the math in order to figure out which of the choices is correct. Use the fact that on SAT questions, it's extremely rare for SAT questions to be faulty.
Right. And
unlike the real world, in the SAT, exactly one of the choices is correct and the other 3 are wrong.
Right.
So you could use that in making a decision about which one to pick.
Right.
Okay. Now, none of this will help unless you know what the absolute value thingy means.
That's right. Yes.
Okay.
Yeah.
If you have no idea what these silly bars are, if you have no idea what the bars around some expression mean, you have homework to do.
Right. You're sunk in this question. And that
you're not sunk. You're not sunk because it's better for you to see bars on sample SAT questions for the first time than it is to see the bars on the SAT question when you take the SAT. No,
but I'm saying if you don't know that. If you don't...
And so when you look at SAT questions to prepare for the SAT, when you find something that you don't know, it's a clue. You have to learn it, find out about it.
Right, of course. But,
so one way to find out about it is to watch videos like ours.
Yeah, but we're not into
and so we are going to, for those people who, so if you, for those of our audience who know what the bars mean, you could leave. We solved it for you. We explained how to approach it, and we did the solution.
You should leave the
sooner. So now,
because you have better things to do.
Please, if you know what absolute value is about, you could turn the video off. Joel and I will say goodbye and come back later. We're now going to explain what bars stand for. The name of what they stand for is absolute value function, and we'll teach you what that means.
Okay, but I guess everyone's already left who doesn't know. But something we like to do for every time we meet is discuss what's the main idea of this question / what, when they designed this question, what was the key concept here? Really, the key idea is exactly what Seth said. You got to know something about the absolute value function. That's what they're testing.
Two ideas. Two ideas. The main idea is, in one sentence, in one phrase, solution to an equation with the absolute value function.
Fine. Yeah, but that's okay, fine. But let's just talk in regular English. You got to know what the
absolute value function is. The main idea is solving equations. You have to know what an absolute
value function is. And then, yes, you have to know. Yes, you also have to understand what an equation is. And you have to know what the absolute value function is. Those are the two key main ideas to this problem. Right, exactly. Okay, so that's also useful. Okay. So when you're studying, make sure you understand both. The takeaway is make sure you come out of this understanding what an equation is and how to deal with it, and what the absolute value is. So, yeah, okay. And Seth, do you want to talk about what the absolute value function is? Looks like you're dying to do that.
Yeah, so the absolute value, when you have...
let's give you some space.
Absolute value. So surrounding an expression with bars it signifies the expression the expression including the bars. Wait, what I scribbled disappeared.
Yeah, I know. I took it away. I'm sorry. I made a mistake.
I'll put it back. Yeah. You have some junk, and there are these vertical bars around it. The whole expression involving the bar that surrounds the thing with the bars is called the absolute value of the number that's enclosed in bars. Now, let me tell you what that means. For this to make sense, this must be an ordinary number or an algebraic expression standing for a number. Now, a feature of numbers is that they fall on the number line. There are the greater than or equal to 0 numbers, and there are the less than 0 numbers, right? And so what it means, what the absolute value of this number is equal to the number itself when the number enclosed in the absolute value signs is greater than 0, and also if it's greater than or equal to 0. So what you do is if you think of the number in here, if you know it's positive or 0, the thing in the absolute values denotes the very same thing.
Right.
The other case is the thing inside. And the other case is that the thing inside the bars is negative.
Yeah.
Right? It's a negative number.
Okay.
That means the thing inside is less than 0, in which case it's negative. Then the absolute value of it equals the negation of the negative number.
Which makes it positive.
Which makes this, so the negation of a negative number is positive.
Right.
So another way to say it is that you could think of negative numbers to be ordinary numbers that have a minus sign in front of them, which means that they're kind of opposite the numbers you first learned of as a kid that are only positive numbers. Right. So you could think of a negative number as a variant of a positive number, and the positive number is the positive version of the negative number.
So why did you just
So, for example, if we take the absolute value of 6, 6 is a positive number, and so the absolute value of 6 is 6.
Yeah.
The negative case, the absolute value of negative 6 is 6.
Yeah, right. Yeah.
So I hope we explained. Could you add something to my explanation of absolute value?
First of all, I want to make it a lot shorter. shorter.
Make it a lot shorter.
Make it a lot shorter. I mean, the other thing is, first of all,
but still, don't be misleading.
I will not be misleading. First of all, operationally, if you have something in here and you take the absolute value, it has the final answer must be greater or equal to 0. If you have something in here, the answer must be greater than or equal to 0. What it is, it's the positive version of whatever's in here. Well, Seth is a PhD in math, so Seth's being very particular. So I'm stuck because I only have a PhD in mechanical engineering, so I don't talk like specifically. But let's choose examples. If you have the absolute value negative 20, it's 20. So if you have a number in here, it's really fairly easy to understand what it means. It means you have a number line. The absolute value is a measure of how far you are from 0 on either side of the number line. It's a measure of the distance away from 0 on a number line, and distances are always positive. So if you are over here at negative 100, you are 100 whatever meters, inches, miles away from 0. So the answer is 100. So it's nice if you have numbers in the absolute value. It's nice to think of it as being on a number line, and just how far are you away from 0? Either way, it doesn't matter which direction. That's the answer.
Okay, very good.
Okay.
Well, so this concept of distance from the origin on the number line. Let me give another related concept.
Yeah.
Given by the word magnitude.
Yeah, but today's Throwback Thursday. No one's gonna last if we keep going.
Okay, all right.
We gotta move
magnitude
on.
is sometimes used for absolute value.
Move on because we really
So I think we beat absolute. We taught you for those people who didn't know what absolute value was about. We expounded it.
Yeah.
And now it's part of your knowledge of math. And next time you see an absolute value problem, you'll know what it's about and you'll be able to answer.
Yes, exactly. Okay. And I should have said it earlier before we lost everyone that I made a mistake procedurally here in that you should invest, Seth said it here, you should invest like a 0.2 of a second when you're reading the prompt just to see if it's faster to check the choices. I didn't do that. I just did it the regular straight way, following your nose, which was not the fastest way of doing it. Okay.
Well, I think it is conceptually important. Yes. It is conceptually important that a solution means that when you plug it into the equation becomes true.
Right.
A solution, that's what a solution means. I think a pitfall for people learning math is that they confuse what a solution means with a method for finding a solution.
Right.
Yeah. The methods for finding the solution there's a range of them, and many of them are complicated.
Right.
And sometimes questions like that, it is easier to directly check whether a number is a solution by using what it means than it is to follow a procedure or recipe or habit that's taught in school for one of many methods for finding a solution.
Yes. So direct check, definitely, absolutely, direct check was the optimal way to solve, the optimal way to get the answer to this question. Clearly,
if it
direct
works
check.
to this question,
direct check was optimal here. So it's a good idea, and I'll try to learn from my mistakes to spend 0.2 of a second to look at an equation and say, hey, should I just do direct check? Okay, it's Throwback Thursday. Yeah. So today we have a Throwback Thursday question. We go back 20 years or so, I don't know how old this book is, to see what questions were like 20 years ago before they basically asked you what you learned in school. They had some weird questions. They had some really weird questions on 20 years ago. So here we go. Let's look at that question. Oh, by the way, we are correct. I checked the answer sheet. We don't have them worked out answers anymore for the SAT, but it does say, and it does register this question as easy. This is considered an easy question according to the SAT people. And it falls into the group of passport to advanced math. Okay, anyway, here's our Throwback Thursday question of the week. Okay. Here we have digit of n.
Question of the week.
Digit of n. For any positive integer n, the symbol circle n represents the number obtained when every digit of n except the leftmost digit is replaced by its corresponding digit in the second column of the table. Okay, looks like a function, some sort of weird rule. For which of the following is the circle of n less than n? Oh boy.
Oh, so you have to make it bigger. So it makes all the digits bigger. It makes all the digits bigger except for the last one.
Right.
Okay. So that's a good question. Yeah. So wow. If you make the digits to the right bigger, so how could you? Okay, but except for one case. Aha! It makes all of them bigger. No. If the digit is a 9, it makes it smaller.
So what Seth's looking for is
so let's find numbers where there are 9s.
Right.
Well, this one Well, unfortunately, it makes the 9 into a 0, but it makes the 4 into a 5.
Right.
So it makes it makes the whole number bigger.
Oh, except
this
the
one,
leftmost digit.
It makes the 9 into a 0, making the whole number smaller. But since the 9 in the second position is higher significance, it's most significant among the digits except for the first digit. So this, making this 9 into a 0, makes this number smaller than the original number. And so simply by looking one number at a time, we found one case. So we got the answer. Why don't we need to look at the other cases? Because in the SAT,
we know.
There is one and only one correct answer given in the real world.
I know, Seth. It's your shtick.
In the real blah, 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 blah. Okay, so, and notice, in none of the other choices is the next to highest order digit equal to 9.
Right, and the leftmost digit
and in
doesn't
fact,
matter.
All of the numbers if you look at the next to highest digit, they're all less than 9 except for choice B.
Right, and here the
so I did not think of at first concentrate on the next to the highest order digit. My brain wasn't fast enough to realize that. So what I did was I looked at the choices. I began with choice A. And I applied the operation, and I realized why choice A was wrong.
Good job.
Okay. And then, fortunately, for sort of good luck, choice B actually fits the criterion. And choice B is the correct choice. And so choice B reveals how easy the general principle. So I realized that what the general principle was only after I started working on the problem beginning with the first choice.
Right, so Seth started playing with it. But Seth, no. But before you began, you were really smart in spotting the pattern that all the numbers go up except this one. That is a really good, important pattern that you spotted immediately.
Part of that was I thought I originally had the thought in my head that I originally had a wrong thought that the operation takes digits and makes them bigger.
Okay.
I was misled. And then I read the question more carefully and realized it's not that. That's not the pattern. It doesn't make every digit into a bigger digit. It makes most of the digits into bigger digits. But when the digit is a 9, it makes it into a 0.
Right.
The thing is, I was misled. I was misled because this table, the whole table, has the following significance. When you have, 3, you have a bunch of digits in the number. Here's our number. And you add 1. What happens is when you add 1 to the first digit, the lowest order digit of a number, what you get is this table, the double circle function of this digit.
Right.
The way you add 1 to a single digit is use the table. If the last digit is a 9, the answer digit in the sum is a 0. But in long addition, you need to carry the 1.
Yeah.
It's 0 with a carry of 1. See?
Right.
And then when you carry 1, you apply this function. And if the answer is 1 through 9, you don't carry a 1 to the next one, and if it is a 0, you carry a 1.
I don't know what you're talking about.
What I'm talking about is how do you do like 898.
Okay.
How do you add 1 to that?
But how is that relevant here? You're changing it.
It is relevant. It is relevant because the way when you add 1 to this number,
0.
Hold on. When you add 1, you write a 9 here.
0, 9.
Yeah, you write a 9 here.
Right.
With carry of 0, and so you copy the 9 here.
Oh, you're going through and you're saying, what does this table do? This is an instruction to adding 1.
Yeah. Now, if you have 8, 9, 7, 9, 9, and add 1 to it, what you do is 9 plus 1 is 10. But 10, when you get a 10, it means that you record the 0 for the number of counts excluding multiples of 10, and a carry of 110.
Wait, what are you talking about? This table.
I'm talking about. I told you what I'm talking about. See the box?
Yeah.
See how the box shows an example for the algorithm of adding 1
to
a long decimal
but that's
expression.
Not what the box is telling you to do.
No, this is what the box. It is what the box is telling you. The box applies to adding the 1 to the first digit.
No, but what about this number, 99? Apply the box.
Okay, then what happens is, if you add 1 to 99, you apply the box to 9. You carry the 1, and then apply the box to 9 again. If you have an 8, 9. Don't interrupt.
It says
if you have 8, 9. Hold on. My point is, except the lastmost digit.
Yeah, so you can't change the number.
Okay, the lastmost digit. Yeah, so the box operation does this to all the numbers. Okay.
Forget it. Stop going into this.
Oh no. You're right.
Yeah, I'm right. So forget it. Forget everything.
Oh gosh. The circle operation is an artificial operation.
Yes.
The artificial operation that was dumb. That's a dumb extension of the operation you do on single digits.
That's right. So stop everything that's said is just overkill. Just forget it. Just forget it. Just forget it. But what's really the big takeaway is that you spotted the pattern that all these numbers go up except for the last digit, so it's intelligent. First of all, you ignore these because these 9s are here. That's just don't worry. These don't get affected. But Seth was really smart to go after this and see which numbers go down, and it's clearly this one. Okay. Yeah. So let's see. The book doesn't say in this particular book. By the way, everyone must admit, hand raise, weird question that you will not see in the post-2016 test, right? We all agree that you will not see a question like this. Okay, so let's look up the answer just to be sure, because it's such a strange question. It turned out it was section 6 in this test, the last question, if anyone got to it. Where's the answer? Come on. Sorry for the delay. Here it is, section 6. The last B. B is the last section. Oh, they called it difficulty level 4. They didn't make it difficulty level 5. They said difficulty level 4.
Okay. Yeah.
Well, whatever. Okay, question E.
Well, this is...
Question 9 was difficulty 5.
Mathematically, this is a poorly posed. This is an ill-posed. It is an ill-posed definition.
Yeah.
Why? It says it's a positive integer n.
Okay.
So we're going to use a different color for black. I'm going to use blue. No, I'm going to use a different color. Purple.
Hold on one second.
N is supposed to be an integer. That means it shouldn't matter how you write n. So if n is 9, you get a certain number, you get a certain answer. Okay, what am I doing?
Who cares about the question? We're done.
Hold on.
People have better things to do.
But if n is 009.
Yes. If you put a leading 0 in front, then it works. Yes.
So these two expressions they express the same integer.
Right.
9, 5, 4 make 9.
Yeah.
Apply this operation, and you get 9. Apply this operation, and you get 0, 9, 0, which is 90.
Okay, look, you're playing around. Let's stop wasting people.
No, I'm criticizing. The thing is, what they should say. N is a decimal expression for a positive integer.
Look, come on. What difference does it make?
There's a difference between the expression for an integer and the integer itself.
Fine, I see what you mean. Yeah.
You know, like 3 plus 4 and 7. This has 4. This has 3 symbols, and this has 1 symbol.
Right.
They're different.
Okay.
But similarly, the leading 098 and 98 represent the same integer, but they are 2 different decimal expressions.
Yeah. Okay.
So this definition is meaningful. Only it is a definition of a symbol in mathematics should give the same answer when it is applied to the same thing to apply it to.
Yeah, but like, so what? You know, this is a weird. They made up a question. This is not supposed to be tough, straight, perfect math. This is just a stupid question on the SAT. But this was an SAT
that shows question. How. So what we enjoy doing is identifying stupid things in the SAT.
It's not
That's
stupid.
Fun.
It's not stupid. It's artificial. Okay. Look, I can say anything I want. I can create any function I want, right? I'm not even sure this is a function. I guess it's a function.
No. It's
an artificial rule.
It is.
Did I spell artificial right?
This is one of the very few. It's actually very rare that definitions in the SAT are faulty.
Yeah, technically, right. Are
technically faulty in the sense of mathematics.
Fine. Okay, but let it go. Let it go. It's a very artificial rule with a faulty thing at the level that you are at, which is a PhD in math from MIT, and has been a professor emeritus, and is now a professor emeritus of computer science at SUNY Albany.
in a little bit of mathematics, but a lot in computer programming.
Yeah.
Symbols for things like numbers are important.
Yeah. So this question doesn't pass muster at the PhD level, at the PhD math level. Okay? But let it go. But we're not at the PhD math level. We're at the 11th grade, 10th grade, 11th grade high school level. So just let it go. It's okay. But anyway, we do admit this question is not, you wouldn't see a question like this on the modern SAT. Oh, wow, we are really done. 35 minutes. We'll go to our analytics later and see if anyone at all survived 35 minutes today. I think we really took advantage and overdid it. But okay, so that's it. I guess we're done. We already introduced ourselves. That's right, we said something. So here we are. We're trying to let's make it fast. We're just trying to help you figure out how to do math SAT questions, giving you all sorts of different angles, and hopefully we discuss things you wouldn't hear anywhere else. That's about it. And you just practice as many SAT questions as you can and work on your weaknesses. Whatever questions you're getting wrong, study those subjects and get better on those. And Khan Academy offers questions that are targeted for each topic that's on the modern SAT. And just study as many SAT questions as you can. Learn from your mistakes and learn the try to ask yourself on an SAT question, what's the key point? And build up a list of key points. And I personally would write a cheat sheet of list of key ideas and build that up. That's about it. Okay, and you can always, please like, dislike, please give us comments on our videos. Can't wait to hear what people say about this one. And if you have any SAT math questions, then pass them to us to our email at satmathquestionoftheday@gmail.com. And we'd be happy to take a break from all these SAT questions that we do and do the one that you send. Okay, everyone, have a great day.